Welcome to Advanced Functions. I am Don Paras, your personal student tutor, here to prove one of the laws of logarithms.
What are logarithms? In advanced function, log, also known as logarithms, are an inverse function of exponential. Logarithm undoes an exponential function. We use logarithms to deal with series of multiplication. In other words, it is like a mathematical concept with notation. According to life science, logarithms are derived from Greek words logos, meaning ratios, and arithmos, meaning numbers. Can you think of some examples as to why we use logarithms? With those in mind, let's review some terminology. Over here, b to the power of y equals x is our exponents, whereas y equals log base bx is our logarithms. It is important to know the difference where b is the base and y is the exponent or index and x is the answer. It is important to know the differences of exponent and logarithms to understand how to evaluate. Now let's evaluate as to how we can put exponents into logarithms. So 7 to the power of 3 equals 343. This can also be rewritten as 7 times 7 times 7 equals 343. Now with that in mind, let's look back on our exponents and see what we can label. So 7, 3, and 3, 4, 3. Now can we label our b, our y, and x? Yes, we can. With those in mind, we can rewrite that as our log. So that'll be 3 equals log base 7, 3, 4, 3. Now it's important to know the difference between b, y, and x, just so that we can convert them to our exponents, to logarithms, etc. Now, notice the difference. The bottom is a logarithm, and the top is our exponents. Now, let's grab ourselves a whiteboard or some paper and try some logarithm application questions. Now, write this down. Here is an example. Log to the base of 5, 25 equals y. We are going to evaluate for y. Now, it is important to convert your logarithms into exponent to help you see more clear. So 5 to the power of y equals 25. Now, if that doesn't work for you, you can also change the 25 into 5. So you can rewrite this as 5 to the power of y equals 5. And you could essentially put an x on there, on that little blank to help you see it. But with some guessing checking, you can understand that if you do 5 to the power of 2, you'd get 25. Therefore, y equals 2 because 5 to the power of 2 equals 25. Now some pro tip, just remember to always convert your logarithms into exponents to help you evaluate your variable. Now, when evaluating logarithms, there may be some problems. When dealing with logarithms with a base other than 10, we use the change of base formula. The change of base formula appears like this. Log base b x equals log x over log b. Now, the base for log x and log b can be of any number, and it helps to put a variable because it will cancel out. However, if it helps you to think, you may assume that the base is 10. This approach is very helpful when evaluating logs from calculators that only recognizes 10 as the base. Now grab yourself a whiteboard and let's convert our logarithms to the change of base formula with this application. So log to the base 2, 37, can now equal to log to the whatever base, 37, over log to the base of whatever 2. Now, if that doesn't help you, you can always assume in grade 12 that the log would be 10 for the base. From what we learned now, we can now show proof. So, let us now put our basic log format. So log to the base of b, x equals y. This function can now be rewritten for the exponent for base b to the power of y equals x. Now, from here, you can go ahead and take the logs of both sides. So log to the base of whatever b to the power of y equals log to the base of whatever x. Now, if you still can't see it, you can always assume that the base would be 10. However, the base can be of any variable, considering that it will cancel out later. Now, with the exponent law, we can move the y in front of the log, which will now be rewritten as y log base of whatever b equals log to the base of whatever x. Now, we're going to go ahead and evaluate for y. So dividing both sides of log b, you now get y equals log to the base of whatever x over log to the base of whatever b. Now, you can go ahead and still assume that the base is 10 if you'd like. However, it can give any variable of your choice. Now, as you can see, y now equals to y, end of the logarithms. Therefore, the change of base has proof as it correlates to the logarithms and exponents. Therefore, y equals y. In conclusion, we use the change of base formula in logarithms to evaluate y when the base is not a factor to the exponent or greater than 10.